Welcome back to More Fun with Finance. I'm Dr. William Elliott, coming to you from my studio in beautiful uptown Shaker Heights. And today's subject is time value of money. This is Chapter 5 out of Ross Westerfield and Jordan, 2024 release. And this TVM, time value of money stuff, probably one of the most important things that you can learn as a new student of finance. And it will go a long ways towards your better understanding everything from here on out in finance. So if you don't have a good handle on time value of money, you are not going to be very successful at this. Now, at first it might seem a bit mysterious, but really when it boils down to it, it's very, very basic stuff. We're just talking about how interest rates affect our investments, or how returns that we get affect our investments. And we're talking about various types of compounding periods, simple interest, compound interest, and so on. I'm going to break it all down for you so that hopefully it will be real clear the first time you go through it. This chapter and the next chapter, which gets into more complicated time value of money computations, will be the things you'll want to focus on. If you have any difficulty with this, make sure that you get in touch with me. I'm happy to work through additional problems with you, things of that nature, just to make sure that you get this. Without this foundation, I can't emphasize how much it's going to hurt you in the long run. So spend the time and get this material down. So let me switch over to the slide deck here, and I'm going to get out of the way. And here we are in Chapter 5. So I'm going to be switching back and forth between the slides and a calculator that I have. The calculator is right here. And actually, it's really like your calculator when you look at it this way, but it's just more convenient for me to function in this with it in the landscape mode. All right, so we're going to be working with these keys in the third row. That would be the N, the I/Y, the PV, the payment, the PMT, and the FV keys. Let me get back to the slides though. So first thing here, so we're going to look at future values and compounding. We're going to look at present values, which are really the reverse of future values. And we're going to look at some other issues related to this. Now, before we go any further, the authors don't use this extensively, and there's nothing in the slides that relate directly to this, but timelines are going to be your friend. Again, I can't emphasize how important this material is and how much a timeline will help you to get it right. All right, and by a timeline, I simply mean, I'm going to jump over here to the blackboard, and I simply mean literally a timeline. All right, here we are at time 0. Usually we're at time 0, the present, and out to the right is out to the right is the future. So this might be year 1, year 2, year 3, year 4, and so on. The other thing to keep in mind in all these cases, unless stated otherwise, we're always viewing the cash flows as occurring at the end of the particular period. So when we talk about a cash flow today, that is right here. That's at time 0. But if we talk about the cash flow for year 1, we're assuming it occurs at the end of year 1, which is also the beginning of year 2. But keep in mind, it's the end of the period. So if we want cash flow 3, year 3, that occurs right there. Remember, this is 1 year, 2 years, 3 years. So it's 3 years away from us. If you keep those simple rules in mind, and if you use this type of device, you will be much better off, I guarantee you. This visualization is very helpful. So we would be doing things, for instance, let me clear off some of this. Clear that out. Clean this up a little bit. So, for example, let's think about we expect to receive $100 in year 4. That is $100 at the end of year 4. Now, that means it's 4 years away from now. So, to figure out the present value of that, we're going to bring it back 1 year, 2 years, 3 years, and finally 4 years. We're going to be discounting it back. Anytime we move money from the future back to the present, it's discounted. It gets smaller. The value gets smaller. Anytime we move dollars from the present out into the future, they get grossed up. They get bigger. And again, if you remember that, that will help you to check numbers and make sure that you're getting at least the right direction. Another thing to note before we get into this is that, especially when you're using your calculator, you're going to be putting in, say, you invest $100 today and you want to know what it's worth in 5 years if you expect to earn 10% on it. Well, when you put in 100 present value and you put in 10% as the interest rate, and you put in 5 as the number of years, and you calculate the future value, you're going to get negative 161. And you might go, well, wait a minute, why is that negative? Well, it's not really negative, but think of it this way, is that if you're investing $100, aren't we really spending that money? We've got a cash outflow. We're not spending it, but we've got a cash outflow. We're putting it in the bank, right? So really, correctly, we should put in our present value as a negative 100. We invest $100, and then in 5 years, when we calculate that future value, it's going to come back positive because that's a cash inflow. The bank is returning our $100 plus the $61 of interest. Let me just show you, since I've got the calculator open here. Now, so that same example I was using, I've got $100, and that is present value. Oh, by the way, always clear work and then clear the entries so that these registers are empty. And the reason is for instance, in this case, I don't want to use the payment key. This is over in the 4th column, 3rd row, PMT. I want that to be 0. So by clearing my work, I get that for sure. I could make doubly sure and just enter 0 for payment. But either way, make sure your registers are always cleared. Also, make sure that it is 1 period per year, and never deviate from that. It's trust me, again, that this is much easier to leave it set that way. The calculators do allow you to do multiple payments per period, per year, effectively. But if you forget to change that setting, it's not an obvious setting. If you forget to change it, you get all messed up. All right, so just a few tips at the outset. Oh, I was going to do that computation. All right, so here we go, $100. And we're going to make that a negative because we're putting that in the bank. And that's going to be our present value. All right, and we said 5 years, right? So 5, and N is the year or number of periods. And we said 10% was our interest rate. And we enter our interest rates in percentage terms. So I'm putting in 10, not 0.1. 10 is I. That's the interest rate per period. And in this case, it just happens to be years. Then I'm going to compute the future value, that FV over in the far 5th column, far right-hand column. So I go up to the upper left, the CPT key, compute, and then I tap on future value. And I get $161.05 approximately. And notice that that's a positive. I entered a negative. Now, had I entered a positive for my present value and then computed the future value, that's where you get that negative. And you might wonder, why is that negative? Well, it's always the opposite sign, because we're assuming there's a cash outflow, then the other payment has to be a cash inflow, or vice versa. All right? Okay, I think that should be it in terms of tips and tricks. Timelines, super important. Use those, please. You will thank me for that. All right. So, time value of money. Why do we have interest rates anyway? Uh, I'm not going to go into the details that you should have already gotten in your econ classes, but let me just refresh your memory in case you took that class a while back. Talk briefly about what drives interest rates. And it really has a lot to do with what we call utility theory in economics. All right. Utility theory is discussing basically how much utility an individual might get from something. So let's talk about it in dollar terms to be very specific. So if I have $100 today, what is that $100 worth to me in the future? I don't know. Might be, 110. It might be 105. Certainly not less. Or let me state the question a little bit differently. If I were to give that $100 to somebody else, in other words, I wouldn't have use of it, and they would give me back some amount in the future, say 1 year from now, how much would I want back from that person in order to feel at least equal to where I was today when I had the $100? Well, what am I going to think about? I'm going to think about things like inflation, right? We just went through a period of very high inflation, so that's certainly something I'm going to think about. What do I think inflation is going to be? Well, we just got an announcement that inflation was at 2.9% over the year, which is great news for the economy. It's getting back down to that normal level. The Federal Reserve Bank usually looks at a 2% target, but 2.9 is a heck of a lot better than where it has been over the last 3 or 4 years. So, okay, let's assume that it's going to be 3% over this upcoming year. So I want at least an extra 3%, right? Because my purchasing power would be diminished. If I just got back the $100, my purchasing power would go down. So I want to get back actually $103 to maintain the level of purchasing power that I have today with that $100. What else? Well, I'd rather have that money right now. So you're going to have to make it in my interest to lend you that, even if you're going to pay me back 103. I'm kind of on the bubble on that one. Make it worth my while. Maybe pay me back 105. Okay, 5% interest, which is about what interest rates are today, and in a short-term yield like that. So yeah, okay, now I'm getting a real increase of 2% approximately. Mind you, this is not an additive, it's a multiplicative relation, but it's almost 2 anyway when we're talking about such small numbers. So 3% covers the inflation, another 2% just to make it worth my while, and I'm happy. So I give you $100 today, and in 1 year from now, you give me back $100.05. Okay? What if I reverse that? That's future value. All right? I'm calculating a future value. I'm taking the 1 plus the decimal equivalent of the interest rate times the $100. So that would be 1 plus 0.05. So 1.05 times 100. Let me just write it out. Okay, that's a future value. On our timeline, we start with time 0 at year 1. Here's our $100, and here's our 105. So we give somebody $100, we lend them $100, and they return it to us with interest at the end of the year. So I'm gaining $5 over the course of that year. 3 of it accounts for expected inflation, 2 of it accounts for making it worth my while, and the fact that it's risky because, well, maybe you decide not to pay me back. Maybe inflation's higher than 3%. So I've got risk in there as well. That's why I want that extra 2% on there. So that's a future value. Now, if we were to reverse that and to say, oh, well, here's year 0, year 1, $100 in a year, what's that worth today? What would I be willing to pay somebody today to receive $100 in the future? Well, let's say that our interest rates are still 5%. So what would we need to do here? Well, let's look at this equation right here, because I think that's going to help us. So we could say we're going to replace this 105 with 100. And that's equal to, now this is what we're looking for, right? This is the PV, present value. This is the future value. And so we're looking for that, and we're multiplying that by 1.05. So effectively, with a little bit of algebra, we could find out that x is equal to 100 divided by 1.05. Let's go to our handy-dandy calculator here. Okay. All right, so let's clear our work, and let's clear the system in general. Okay, so we have $100, and that's our future value. And we have 5%, and we have 1 year. And I want to just make sure my payment's at 0. And I'm going to compute the present value. I get $95 and about 24 cents. So if I were to pay $95.24 for an investment that would yield $100 in 1 year, I effectively am paying, or I'm receiving, a 5% return on that particular investment. And again, I'm assuming that the risk of this investment is equal to the risk of the other investment that I was just talking about, the lending. But obviously, if this were to be 105 at the end of year 1, then the answer would come back as it would be worth $100 today. So I can go either direction with this. All right? Future value compounding. So already did it for you, but here's another example. 1 year at 10%. Well, what's 1 year at 10%? We've got 0 and 1, and we've got $100. We get 10% over this period. So 0.1 times 100 is $10. Plus, we get our principal back. All right, so there's my 110. And actually what we can do is when we take 1 plus r, right, 1 plus r right here, we get 1.1. That is our future value factor. And then we multiply that by the amount of money that we're putting into this particular investment. And again, if we wanted to go to the calculator just for practice, please follow along too with your calculator. I'm going to clear the work. I'm going to clear just the screen. And we have $100, and that's our present value. We have 10%, that's our interest rate. 1 period. Oops, 1 period. And I'm going to zero out the payment and compute future value, $110. Okay, so these are pretty simple single amounts for multiple periods. Now, suppose we want to do this for more than 1 period. Now we get into what really makes time value of money and compound interest so terribly important in finance, especially as our investment period lengthens. As our investment period gets longer and longer and longer, this becomes really huge. So if we're talking about a 30 or 40 year investment period, we can really make some hay in the stock market. And over those sorts of windows, historically, the stock market has returned an excellent yield. All right, so how do we actually compute this, and what else matters here? There's one other thing that I want to remind you all of, is that when we have a compounding period, say for instance we're compounding every year, what that means is we're taking the principal that was originally invested, adding to it the interest that was just earned over the prior period, and then we're taking that sum, principal plus the prior interest, and we're growing it at the interest rate that we agreed to for the next period. So we're getting not only interest on our principal, but we're getting interest on the interest from the prior periods. And when we get out towards year 20, 25, 30, all of a sudden that becomes an exponential. That relation is an exponential relation, and it really drives the values up. We'll see that later on, but for the moment, just recognize that there is interest on our interest when we have multiple periods and we have compound interest. You have to set that up in advance, right? When you go to your banker, and if they say this is simple interest, you're not going to get any interest on your interest. If they say it's compounded daily, you're going to get interest paid every day, and that's going to get added to your principal, and then the next day is going to be that principal plus the prior day's interest that goes on to earn interest over the next day, and so on. All right, here's a simple example. Here we have just a 2-period model. So we're looking at time 0, time 1, and time 2. And we start off with $100. And the first period is just like what we computed. We're using, 10%, right? We're using 10%. So at the end of period 1, we have $110, just like the prior example. Now, we take the entire $110 and we earn 10% on that. So what is that? Well, we know that $100 gives us $10 more of interest, and another $10, 10% of 10 is 1. So it's another $11 in interest. So it's 110 plus $11 over this period. So we have $121 at the end of year 2. Now, again, let me just jump back to the calculator and practice, right, on the calculator. That's what we want to do. And so here we have $100 present value, and we take that for 1 period, 10%, zero out the payment, compute future value 110. All right. Now that's our starting value for the next year. So let's put in 110 now into our present value. Kind of move yourself forward to that next year. We're at time, if we go back to here, we've just moved ourselves to this position. All right, so now we have 110 present value, same 10% interest, and that's already loaded in there, so I don't have to do it again. Same 1 year in N. Now I'm going to compute future value, and lo and behold, yes, it comes out to be 121. That's the $10 interest on our original principal, plus an additional dollar interest on the $10 we received in the first year. All right. Now, there's a shortcut to this, though. I don't have to do it iteratively. I can do it all at once in the calculator. That's pretty easy. Let me show you the changes I would make. So we're going 2 years now. So N is 2. I is still 10, so it's periodic, 10% each year. And the original value is 100. Now I'm going to compute future value, and lo and behold, I get 121. Now I can do that for any number of years. I could do that. I can change this to 5 years. What do I get after 5 years? I'd have $161.05. What about 10 years? $260 nearly. $259.37 to be exact. Right? So you kind of see how this works. It's pretty easy, especially with a financial calculator. So these things are worth their weight in gold. All right. So just to emphasize, it's interest on interest. That's what compounding means. And the longer our horizon is, the more value we get out of that interest on interest. It's one of these functions that, if we plotted it on a graph, it's exponential. It goes like that. It's not linear. It's exponential. And this is, we're talking about 30, 40 years out here. Back here, we're at 10 years and so forth. All right. All right. So now let's move into future value. So here we're taking $1 and moving it forward in time. So we're grossing it up. $1 becomes more than $1 when we add interest to it. When we look at the formula here, future value is equal to the amount. In this case, we're just calling it $1, times 1 plus the interest rate. R is our interest rate. And we're going to raise that 1 plus R that's in the parentheses to the tth power, and T is the number of compounding periods. So in this case, if we think about it as a year, we compound on a year, and we've got 2 years, T is 2. If we compound it monthly and we have 2 years, T actually becomes 24. Now, mind you, R has to be adjusted if we move from annual to monthly to weekly to daily. R is usually stated in nominal terms in annual or per annum, right, is often used. But it may say the rate is, say, 12% per annum and monthly compounding. Well, that means that at 12% per annum, monthly would be 1% for every month. And then we'd be compounding. In other words, we'd be getting the interest from the prior month, and then that would be reinvested along with the principal in all future months. Here's an example going back to our $100 investment. If we have that $100 invested at 10% for 5 years, that becomes $161 and just 5/100th of a penny. So we saw that earlier on the financial calculator. Now, if we look at this over a variety of, various periods, so for 1 year, at 10%, we end up with $110. For 2, we actually, instead of getting 120, we get 121. Instead of getting 130 in 3 years, we actually get an extra $3.10 because of the interest on the interest. Likewise, for 4 years and 5 years. And you'll notice that that interest on the interest piece continues to climb. So in the first year, it was only $1, or rather, if we have a second year, it's only $1. But by the time we get out here to year 5, we actually have $11 of interest on interest. And that's where that exponential piece comes into play. When we look at various different rates, we also see that the higher the rate, the more quickly this compounding has a positive effect on us if we're an investor. Notice the difference here between the 20% column and the 5% column. Over 5 years at 5%, we have $1.27, but at 5 years at 20%, we end up with almost $2.50. So $1.50 more than our original investment, and versus the lower rate, we only get 27 cents more than our original investment. We can do this by, we can kind of figure out these factors without a financial calculator by simply using our y to the x key on a regular scientific calculator. Sorry, this should be y to the x. That x should be an exponent. So it should look like this as opposed to what you see right here. So that way we can take 1 plus whatever our rate is and then raise that amount, hit the Y to the X button, and then type in the number of periods, the number of compounding periods, whatever that may be, and then enter and or equals, and that will get you the factor that would be used. In the bad old days, there were tables like this that would show you all the different rates. You could flip through pages and pages and pages of tables. Now we've got it all just in a financial calculator, quite handy. Now, just a review here. I've already shown you a lot of this, but the keys on the calculator, the 5 keys that are of most interest to us. These are only 4 of them right here. The 5th one is actually the payment key, and we'll actually be dealing with that in chapter 6 when we get into other types of future and present value, time value of money calculations. But the 4 that we're using in this chapter are right here. So future value is FV, present value is PV, I divided by Y is the interest rate per period, and then N is the number of periods that we have invested. Make sure that your calculator is set to floating decimal places. Make sure, and I mentioned this at the outset, but it bears repeating. Make sure that your calculator is set to 1 payment per period or per year. Do not change that. It is just a pain, and the idea behind that is that it was supposed to be easier, but really it turns out that it's not easier. It just makes it more complicated because you forget that it's there and don't do the appropriate inputs. And then one other thing is to make sure that the payment occurs at the end of the period, not at the beginning. And this is actually done on, here we are. You'll notice here in the 4th column, 3rd row down, you see that BGN. All right, so we can actually change that from end to beginning of period. And but you don't want that. If it's set BGN, that's beginning of period, you always want your cash flow set at the end of the period. And so there, we will do that now. Oops. There we go. So we're back to end of period. All right. I think that's it on that slide. Now, compound interest, again, this is just another example of how compounding can really benefit us. Suppose we have an investment that pays us 12% per year. We have $400 to invest. And how much will we have in 7 years? At the end of the 7 years, how much will we have in 3 years? So let's start first off with the 3 years. So we've got our present value, or rather our future value factor. 1 plus R raised to the T. So R is 12. So 1 plus 0.12 is 1.12 raised to the 3rd power. And that gives us a factor of 1.4049. So whatever we put into that investment at 12% for 3 years will yield 1.4049 times that amount at the end of 3 years. So if we put our $400 in there, that would grow to $561.97. Now, if we did this for, say, 7 years instead, what would we get? So grab your calculators right now. Stop the video if you want, if it's far away. But if it's at hand, just grab it. And as soon as you got it, turn the video back on, and we'll walk through that. Okay, everybody have their calculator? All right. So let me clear things out here. So we have $400. So we're going to put that in as our PV. And always zero out your payment, even if you've cleared it. I've found that sometimes I think it's clear and it isn't, and that fouls me up. We've got 12%, all right? And we're going with 7 years. There's my 7 years, and now we're going to compute, CPT, the future value. And that turns out to be $884. So more than double the amount after 7 years at 12%. So you can see, I mean, the market returns anywhere from 9 to 10% is a long run average. And so you can see how that is over just a short course of years is going to pay off in a very big way. If we doubled that period of time, now, mind you, we've more than doubled our money here, but now let's go from 7 to 14 years and see what happens. Remember that 884. Now, if it's just linear, what would you expect? Well, about another, $484. So somewhere in that 12, 13, 1400 range, right? Maybe 1500. But actually, it's considerably more than that. So let's change this to 14 years. Compute future value. It actually turns out to be just shy of $2,000. That's that exponential effect coming in. The longer we hold it. If we doubled that, what would we get? So let's go to 28 years. And future value turns out to be $9,553. Really, really stunning numbers here. And that's where that curve is just going straight up as we get out there to those longer terms. Not quite straight up, but you get my point. All right, so here was this is a 7-year example, just details, so you can walk through that. One thing I do want to mention, at just simple interest, that would be $48 every year for 7 years. That would be $336 rather than $484 of extra income. So that compounding, that interest on interest, is yielding a substantial increase in our outcomes. All right, present value and discounting. So how do we bring money back to the present? Now, when we move it out to the future, it with positive interest rates, it always goes up. It becomes a larger amount. When we bring it back to the present, the reverse happens. It becomes a smaller amount. So in other words, if somebody promises me $100 in 20 years, what would I be willing to pay today to that person? Even assuming that they're good for it and they're absolutely, the money is there. Well, certainly not $100, right? How much less than $100? Well, here's a formula we can use to help us think about that. We're going to discount it. So notice that the factor now, instead of 1 plus r raised to the t, is 1 over 1 plus r raised to the t. This is the single period situation. So we have $400. We need to buy textbooks next year. We earn 7% on our money. How much do we need to deposit today to have $400 in 1 year? So if we get 7%, all right, that means that our $400 times 1 over 1.07, if we started with $373.83, we would have our $400 at the end of the next year. Now, for multiple periods of time, I actually already alluded to this because I read in the T. Notice that back here there was no T up here, right? But here we've actually added that in. So this is the better version of the formula anyway, because when T is 1, this reverts to the prior formula. But so this one works for one period or multiple periods. And T represents the number of periods. And again, whatever this number is, 1 over 1 plus r raised to the t. Another way of writing, just a quick note for those of you, if you're thinking about your math, you can write this a different way. You could write it 1 plus r raised to the minus t, right? If you remember your algebra, minus exponent means it's 1 over whatever is in the parentheses raised to that same t power. So we could write that is the equivalent of 1 over 1 plus r raised to the t. But that whole thing, whatever number we get out of that when we plug in r and plug in t and do the math, becomes a present value interest rate factor. Okay, referred to as PVIF R sub t, where r is the interest rate and t is the number of periods. Now, so let's do an example. Suppose that we need $1,000 in 3 years, and we're earning 15% every year. So here is the factor, 1 divided by 1 plus 0.15 raised to the third power. And so that becomes 1 over 1.5209. And that is a discount factor of PVIF for R of 0.15 and T of 3. That is our present value discount factor. So whatever amounts we have, we just multiply them by that factor. So our $1,000 is multiplied by 0.6575, and we get that the amount we would have to invest today is $657.52. Now, if we wanted to look at that on the calculator, so let's see, let's make sure we've got our numbers. We've got 15%, we've got $1,000, and we have 3 years. Okay? Clear everything. We have 3 years. We have 15% for I. We have 1,000 for the future value. I'm going to put a 0 into the payment just to clear it, and I'm going to compute PV. There's my 657.52 approximately. All right, so yep, those numbers check out, and it's a whole lot easier to do on the financial calculator using those 5 handy little keys on a financial calculator. So here we are with, let's kind of summarize this. We've got a future value factor. This is what $1 today would be worth in some period in the future. We gross it up by multiplying it by 1 plus r raised to the t, and we discount it to move a future value back to today. So it's 1 over 1 plus r raised to the t. So here's another example. Let's evaluate this. We've got, we're looking at a company that proposes to buy an asset for $335, and they find out that they can sell that asset in 3 years for $400. Now the question here is this a good investment or not? And you might think, okay, well, 65 bucks on this, on a $335 investment, that's not bad, right? $65 on a $335 investment, 65 divided by 335, that's almost a 20% return. Pretty good. But is that is that reasonable? Well, given the level of risk of this investment, we are able to find another investment that yields 10% and has the same level of risk as this investment. Now, which one do you choose? And that's 10% compounded annually, by the way. You going to pick A or B? You want a moment? Get your calculator out. Let's try this. Let's go 400, let's go 335. That's what we put in it today. Let's go 10%. That's, oops, sorry, that's our I. Let's go 3 years. That's our N. We're going to zero payment. And we are going to calculate a future value. I get $445.89. That's a lot better than $400. Here's the value right here. So actually, this investment that we first mentioned doesn't look all that great. If it's exactly the same risk as this second investment, and the second investment yields 10% return compounded annually, then we should be either getting more than $400 for this input, or we should be able to buy it for less than $335. So let's say that the 400 is fixed. How much less would you have to see the price go down in order for you to be interested in it? Well, that's pretty easy to do as well on the calculator. So we've got 400 as our future value, and we've got the other figures already inputted here. So 3 for the N, and we have 10% for the I. We've zeroed out the payment. So all we have to do is compute the present value. So if instead of costing $335, the same investment that yields $400 in 3 years, if it costs $300.53, then we'd be interested in it. Then we'd be, we'd be getting that same 10% return that we got in this other investment. Okay, so this one shows really that this whole formula between present value and future value can be summed up into this one equation here. And if we'd rather write it a different way, what do? Well, we've got PV over here. We've got FV over here. If we were to multiply both sides by 1 plus R raised to the T, that would cancel this out, and it would move it over to this side. So we would actually have here 1 plus R raised to the T times PV. So that's the future value, grossing it up. And then present value, and let me clear off these marks and just wipe that away. And back to the pen. So here we're actually discounting a future value back to the present. All right? Okay. How about finding other parameters? Instead of knowing present value and finding a future value, or knowing a future value and finding a present value, where we also know R and T, suppose we wanted to find R. Suppose we knew a future value, we knew the present value, and we knew T, but we're looking for the rate of return that we're getting on this particular investment, which is oftentimes the case when you're doing some sort of a project analysis. And so here we have a situation where if we invest $12.50, we'll be getting back $13.50 in a 1-year investment. So the question is, what rate does that investment yield? All right. So that's an extra $100 on our $12.50 investment, or an 8% return on our investment. Now that's just a single period, and so there's no compounding effect going on there. We can easily duplicate that on our calculator by putting 1 for N, and then 1250 for, and I'm going to make that a negative for my present value because we're paying that out. And then we put 1350 in positive for our return of our investment. By the way, whatever you put in as PV, you have to put the opposite sign on the FV, or vice versa. So one way or the other, one of them is going to be negative. So it's easy to think about it as an example. If I'm investing something, I'm paying it out today, and I get it back in the future. So paying out is a cash outflow, that's a negative. Getting it back is a cash inflow, that's a positive. Suppose that I borrow some amount today and I have to pay it back. So that's a inflow in the present value. That's a positive. It'd be an outflow as a future value. But you get the idea. I'm going to zero out this payment again just to make sure it's cleared. Then I'm going to compute I. And yeah, lo and behold, it checks out. We get 8%. It's always a nice thing when these things work. All right. Now, let's take a look at multiple periods. So we're looking for an R still, but here we actually have 8 periods and we're compounding every period. So here's the situation. Assume we're offered an investment that costs $100 and will double our money in 8 years. So we're going from 100 to 200 over the course of 8 years. Well, let's look at our calculator before we look at the numbers on the slide. $100 invested, and that's a negative. Boom. 200 at the end. There. 8 years. There. 0 in payment. Compute I. I get 9.05%. Let's hope that that's what the slide agrees. Yeah, where is it? Where's the answer? There we go. Right there. They just rounded off, right? And this just goes through the example of how to set this up, either using a financial calculator, or you could actually do it using just a standard scientific calculator that just has y to the x on it. Again, the class requires that you have a BA2 plus. You'll be using it in your next semester as well, and it's kind of handy to have one of these things around. These are great little tools, especially if you have anything to do with business, and in particular if you're in finance. I even walked into, many years ago, this was way back, 40 years back, I was buying a car. I walked into a dealership and I had the monthly payment before the salesperson did. And that actually gave me a bit of a negotiating advantage too, because they knew that I was not going to be fooled by any of their games. Anyway, all right, so now we've already solved for the discount rate. And this is another example. They actually have Benjamin Franklin donated 1,000 pounds sterling to Massachusetts and also to Pennsylvania. And the question is as well, if he were to not have paid it until 1990, 200 years after his death, what would that have actually been worth with different rates of investment? So you can work through this example. I'm not going to belabor it in lecture, though. Couple of additional things here. This is an interesting one because most of you, if you're going to be working in business and you've got your MBA after you finish up a program, you are the probabilities are very high that you're going to have multiple millions of dollars by the time you retire. In fact, if you don't, retirement may not be a whole lot of fun. So here, just getting $1 million is not quite nearly enough. But let's look at what it would take. If you put in $10,000 today and you let it ride for 50 years, what sort of rate of return would you need in order to get $1 million? All right, so again, let's, I'm going to clear my work, clear the screen, and we're going with 50 as our number of years. We're going to be solving for I, so we'll leave that alone. We start with a present value of 10,000. So there's our present value. We want to have $1 million at the end. There's our future value. We're not going to make any payments on this one. Now, obviously, in reality, you probably would be making some payments, contributions every month from your salary to your 401k or something of that nature. But for the moment, we'll pretend we're not doing that. So now compute I. And, okay, did you catch my error? Yeah, I didn't put a negative sign on the 10,000. So let me re-enter that, clear this. So let me put a negative sign there. Now it's going to work. And I get a very weird answer. Okay, something else has gone awry. I'm going to clear this out, start over. 50 is N. 10,000 negative is PV. 0 is payment. Million is our future value. Now let's compute I. There we go. 9.65. And lo and behold, yes, that is the answer on the slide as well. By the way, it never hurts to have some sort of sense of the direction your answer is going to be, so that if you do foul things up, like I did there, totally accidental though, mind you, that you know that you messed up and you need to go back and fix something, right? So be careful on your data entry. It's easy to make those mistakes, as you can see. All right, what if we wanted to find the number of periods given an R and a PV and a future value? How many periods would it take to get to X number of dollars? So here we're given an amount of 25,000 to start. We want 50 at the end. We have a return, an investment that returns 12% compounded annually. How many years would that take? Now the math starts getting, a little bit, the algebra starts getting to be a little difficult when we're looking for R or T. So the financial calculator comes in very handy there. So 25,000, we're going to make that a investment, so it's negative. And we have 50 on our future value, and we have 12%. And I'm just going to zero that payment out. And now let's compute N. I get 6.11 years for that. And yes, lo and behold, there we go. 6.11 years at 12% to double our money, basically. All right. One last example here. Suppose that we're looking at buying a company, Godot, waiting for Godot, and we think that we can buy that company for $10 million. If we had $2.3 million now, and we earned 5% on our investment, how long would it take us to get the 10 million? Well, it's going to be a while. So here is the formula: PV of 2.3, future value of 10, divided by 1.05 raised to the t, solve for t. And so when we do that, so we have, let's see, we have 5% is our I, and 2.3 million, and we're going to invest that, so that's a negative, and we want 10 million at the end, zero out the payment, and we're going to compute N. I get a little over 30 years. It's a little long to wait, and maybe that company isn't going to be available for 10 million. Maybe it won't even be around in 30 years. So that's going to be a while. What if we were to raise the rate on our investment, take a much riskier investment at 16%? How many years would that take? So all we do is change I to 16 and recompute the number of years, and I get just a shade under 10 years. So you can see that this thing is handy for a lot of different reasons. Hopefully this was helpful to you. We're going to be jumping into chapter 6 next, and there things get a little more complicated. So if you've got questions on this one, get to me right now while they're still fresh, and before you get into chapter 6, because if you're already lost, chapter 6 is just not going to make any more sense to you. So please reach out if you do need any help. I'm always here available to give you a hand. Otherwise, have a good evening. Thank you. Bye-bye.